Hi guys. So, welcome to homework page 12 and 13. So you made it to the end. And so I'm going to go over a few of the problems. So for number 1, this is actually the example that we did in notes. And so if we're trying to go from liters of oxygen to liters of carbon dioxide, you first have to set up your conversion factor. So we use the conversion that 22.4 liters is equal to 1 mole. Okay, so liters at the bottom, so 22.4 liters of oxygen is equal to 1 mole of oxygen. Okay, here, this is our mole ratio, and we get that from the balanced equation. So moles of oxygen would be 5, and carbon dioxide would be 3. Okay, and then again we set up our conversion that 1 mole is equal to 22.4 liters. Okay, also notice when you go from liters of one compound to liters of another, this cancels, and so really you're just doing a mole ratio. So 5 times 3 is 15 divided by 5 gets you 3. So you should have 3 liters of carbon dioxide as your answer. Alright, so let's move on to number 2. Number 2 says when 15 liters of oxygen is consumed, how many liters of carbon dioxide are produced? Okay, so we put what we are given, which is 15 liters of oxygen. Okay, so I'm going to set up my conversion that 22.4 liters of oxygen is equal to 1 mole of oxygen. So from here I have to set up a mole ratio to go from oxygen to carbon dioxide. So moles of oxygen comes down and moles of carbon dioxide is on top. Okay, so then that's going to be 5 and 3. Alright, now I'm in moles of carbon dioxide, but it asks me to find liters of carbon dioxide. So I have to set up a conversion to go from moles to liters. And so 22.4 liters is equal to 1 mole. Alright, and then I just put this into my calculator. Right, so 15 times 3 times 22.4, and then I divide that by the bottom. And so I get 9 liters of carbon dioxide as my answer. Alright, so I'm going to move on to number 5. And so for number 5, you're going to be using this balanced equation right here. So number 5 says, if the combustion of ethane produces 78.3 liters of carbon dioxide, how many grams of water would be produced? Okay, so first we have to go from liters to moles. And so we can do so by using our conversion factor that 22.4 liters is equal to 1 mole. Okay, so I'm going to put 22.4 liters at the bottom. Alright, so then my liters would cancel, and now I'm in moles of CO2. And I need to go into moles of water. So I do so by setting up a mole ratio, and I can find that from the balanced equation. So CO2 is 4, and moles of water is 6. And so my moles of CO2 cancel. Alright, last, I want to know how many grams of water would be produced. Right now I just have moles, and so I have to convert that into grams. And so I do so by calculating the molar mass. So remember, 1 mole is equal to the molar mass, which is grams. Okay, so hydrogen is 1.008, but I need to times that by 2, because I have 2 of them. plus the molar mass of oxygen, which is 15.999. Okay, so when we calculate that, we would get 18.015 grams per mole. So we're going to put 18.015 at the top, and that is equal to 1 mole. And so moles of water cancel, and our answer would be left in grams of water. So let's go ahead and put this into our calculator. So 78.3 times 6 times 18.015, and I divide that by the bottom, so 22.4 times 4, and I get 94.5 grams of water. Alright, so for number 6, this is found in your notes, so it's the practice problem that we did in class together. Okay, so that can be found in your notes. Alright, so number 7. It says when 33.1 liters of nitrogen reacts, how many moles of hydrogen are needed? Okay, so we're going to be going from liters of nitrogen to moles of hydrogen. So I put what I'm given, which is 31.1 liters of nitrogen. And first I need to convert liters of nitrogen into moles of nitrogen. So liters of nitrogen go on bottom because you bring your units down and across, and moles of nitrogen go on top. So I'm going to use my conversion factor, that 22.4 liters is equal to 1 mole. So 22.4 goes on bottom, and 1 mole is on top. Alright, from here I can then switch from moles of nitrogen into moles of hydrogen by using a mole ratio. So moles of nitrogen come on the bottom, and moles of hydrogen go on top. And this is going to be my mole ratio, and so this will be 1, because there's nothing in front of nitrogen, so that's said to be a 1, and moles of hydrogen will be 3. And then we can go ahead and put this into our calculator. So 33.1 times 3 divided by 22.4, and we get 4.43 moles of hydrogen. Alright, let's move on to number 9. So number 9 says, for a farmer to get 7.5 moles of ammonia for his field, how many liters of nitrogen are needed? Okay, so now we are given moles and we need to find liters. So I write what I'm given, so 7.5 moles of ammonia. And the way I'm going to get into moles of nitrogen is by setting up a mole ratio. So moles of ammonia, and then moles of nitrogen. Okay, so mole ratio. Next to ammonia, which is NH3, is 2. And then the coefficient next to nitrogen is said to be a 1. Alright, so now I'm in moles of nitrogen, and I need to convert that into liters of nitrogen. So I bring moles of nitrogen down, and liters of nitrogen goes on top. And I use the conversion factor, which I wrote here. 1 mole is equal to 22.4 liters. And then I can put this into the calculator. Okay, so 7.5 times 22.4 divided by 2. And I get 84 liters of nitrogen. Okay, number 10. We're going to be using this formula, this balance equation right here. So number 10 says, how many grams of chlorine are needed to produce 3.4 liters of hydrochloric acid? Right, so we have 3.4 liters of HCl, and I want to know grams of chlorine. So first thing I need to do is convert my 3.4 liters of hydrochloric acid into moles. Okay, and so I use a conversion factor, so 22.4 liters of hydrochloric acid is equal to 1 mole. Alright, now I can set up a mole-to-mole ratio to go from moles of hydrochloric acid into moles of chlorine. So moles of HCl to moles of chlorine. So this is a mole ratio, and so moles of HCl is 2, and moles of chlorine is said to be a 1. Alright, now I'm in moles of chlorine, but I need to find grams of chlorine. And so I then have to calculate molar mass, because I know 1 mole is equal to the molar mass. Right? So chlorine mass is 35.453. I have 2 of them, so that means I need to multiply that number by 2. Okay, so 35.453 times 2, and you get 70.906 for my molar mass. Okay, so now I can then calculate. So multiply everything on top, multiply the bottom, and divide the top from the bottom. So 3.4 times 70.906 divided by 22.4 times 2. Okay, and I get 5.38 grams of chlorine as my answer. Alright, so last problem I'm going to do with you is number 14. So number 14 goes with this balanced equation. It says if a student has 36.7 grams of water react, how many liters of hydrogen is produced? Okay, so I'm given 36.7 grams of water, and I need to go to liters of hydrogen. So the first thing I need to do is calculate molar mass so that I can get into moles of water. So grams of water goes on the bottom, and moles of water goes on top. Alright, so 1 mole is equal to the molar mass of water, and so that's going to be 2 times 1.008 plus 15.999. And I end up getting 18.015. Alright, next I can set up a mole ratio to go from moles of water into moles of hydrogen. So moles of water goes on bottom, and moles of hydrogen goes on top. Alright, so this is my mole ratio, and so I have 2 water and 2 hydrogen. Alright, now I'm in moles of hydrogen, but I need to find liters. And so I just used a conversion factor that 22.4 liters is equal to 1 mole. So I bring moles of H2 down, and I get liters of H2 on top. So 1 mole is equal to 22.4 liters. And then I go ahead and put this into our calculator. So 36.7 times 2 times 22.4, and we divide that by the bottom, which is 18.015 times 2. Okay, and I get 45.6 liters of water. Alright guys, so that is it for the homework. If you need additional help, please go to tutorials or come during Eagle's Nest. And quick reminder, your exam, if you are red day, is on April 6th. that is next Thursday. And if you are Blue Day, it's going to be April 7th, next Friday. Alright guys, that's it.